Good morning all. This is the fifth lecture of chapter electricity. The topic is resistors connected in parallel. As you see from the figure, one resistor R1, one resistor R2, one resistor R3. All these resistors are connected to one point from one side, connected to the other point from the other side in a form of a ladder. So, when resistors are connected pile-wise or in a form of a ladder, we say that resistors are connected in parallel. See from the figure, all the resistors are connected to the voltmeter, battery, key, ammeter. The main point in this figure, you have to learn that the voltage remains the same and the current is the sum of each resistor. Means I is equals to I1 plus I2 plus I3. See from the figure, current is passing through this point. From the B point, it is being distributed in three terminals. I1 in the first terminal, I2 in the second terminal, I3 in the third terminal. As the current is going through one point to another, then the current becomes equals to I is equals to I1 plus I2 plus I3. According to Ohm's law, V is equals to IR. Therefore, I become equal to V by R. I1 become equal to V by R1. I2 become equal to V by R2. I3 become equal to V by R3. See here, V remains constant. Therefore, putting these values in equation 1, we had V by R is equals to V by R1 plus V by R2 plus V by R3. Or V get cancelled on both the sides. We are left with 1 by R is equals to 1 by R1 plus 1 by R2 plus 1 by R3. As the resistors are connected in parallel, 1 by R parallel is equals to 1 by R1 plus 1 by R2 plus 1 by R3. This means that the equivalent resistance in parallel is equal to the sum of the reciprocals of each resistance. The main point here you have to learn that the resistance is the lowest of all these three. If I tell you to add 1, 2 and 3 in a parallel connection, your answer must come less than 1. Okay, this is a graphical representation or the diagrammatic representation of the series and parallel. When two bulbs are in series, both are connected end to end, from one end to the other, to the other, to the battery itself. It is shown by a straight line. When the bulbs are connected in parallel, one above the other, one bulb, second bulb, and it is connected to a single battery. So this is a circuit diagram for two bulbs connected in series. This is a circuit diagram for two bulbs connected in parallel. Now, very important topic, electrical energy. As you must know that energy is the work done. Same way, electrical energy is the work done by electricity, and electricity comprises of charges or in general current. Therefore, electric energy is the work done to maintain the flow of current in a conductor. Work done is equal to charge into potential. As we know that current is equal to charge by time, the charge becomes equals to current into time. Substituting charge in W, we get W is equal to VIT. This is the second form of your energy. First form says that W is equal to Q into V. Second form says that W is equal to VIT. Now, if we substitute the value of V is equal to IR. The third formula for work done or the energy is equals to I into T into IR, or W is equal to I square RT. As you know that energy is calculated in joules, therefore electric energy is also calculated in joules. Next topic is electric power. Power is rate of doing work. Similar basis. Electric power is rate at which electric current is used. Simple formula power, work done by time. This you did in 9th class. Power is equal to W upon T. Substitute all the three equations in here. You get W is equal to I square RT. Substitute I square RT. T get cancel out. Power become equal to I square R. If you substitute R, you get power is equal to VI. So, two formulas for power or three formulas for power is equal to W upon T. Power is equals to I square R and power is equal to VI. As you know that power is calculated in watt. Very important question. What is 1 watt of power? 1 watt is that power when a current of 1 ampere flows across a potential difference of 1 volt. As you did in your 9th class, 1 kilowatt hour is equal to how many joules? 1 kilowatt hour is equal to 3.6 into 10 raised to power 6 joules. Next, if I ask you, what is the commercial unit of power? You must say that the commercial unit of power is watt hour or kilowatt hour. And if I ask you what is 1 kilowatt hour, you have to explain when 1 kilowatt power is consumed for 1 hour. Or if I ask you what is watt hour, you must say that when 1 watt of power is used for 1 hour. See to the concept and then you have to write. If I ask you about kilowatt hour, you have to write 1 kilowatt. If I ask you watt hour, you have to write watt. Very important topic. Heating effect of electric current. As you must observe that when you heat any charge in a any body, the body get warmed up. If you rub your hands will get warmed up. If you use your phone, after some time, your back of the phone get warmed up. That is what we say that. If a current flows through a resistor of resistance R for a time T and the charge Q is flowing through that, then the work done is equal to through the potential W. As you know, W is equal to V into Q and Q is equal to IT. Therefore, W become VIT. This work done is called as heat produced. All the three formulas you convert it here as heat energy. W is equal to VIT, similar basis. Heat is equal to VIT. H is equal to I square RT. H is equal to V square R by T. All the three formulas are being converted into heating effect. Now, when an electric current flows through a wire, the wire heat up. This heating or this electric energy is being converted into heat energy. The greater the resistance of the wire, the greater is the amount of heat produced. This heating effect is used in common electric appliances like iron, kettle, hair dryer. A kettle uses both copper and nichrome wires. Copper has low resistance while nichrome has high resistance. Now the question arises, which material, copper or nichrome, should we use for the heating element for the external wire? and why? Search for the answer and write for that. The answer is we use nichrome wire as it has high resistance, so it will produce high heat. Heating effect of electric current. Example, if you see to the bulb, the ordinary bulb, this filament heat up and produces heat and light. In a light bulb, the heated filament, which is also a resistance wire, become so heated up. Okay, with this we are over with the chapter. These are the in-text questions. Some of them we had done it. If you haven't done it, please do your in-text question and exercise question. If anybody having any problem, just message me out.